Hey guys, this is example 2 in 7.2, okay? So now that we have learned or gone over all of our inverse functions, I can give you any inverse and you are expected to find the solution, okay? So example 2, direction, find the exact value. Again, exact value means no cow. So I'm going to, just like what we did in class, and at first anyway, we went very slowly. So what I'm going to do first is I'm going to say, hey, cosine inverse of 2, in theory, should have a value, an answer, okay? Maybe it's undefined. Maybe there's an answer that we can find. So the first thing is I'm going to rewrite this piece. If I were to rewrite it, I'm going to rewrite it in this form. Y equals cosecant of x, okay? Well, this is now the output of an inverse. That means it becomes the input of the regular. So, and this is the input, so now this is the output. So this is really 2 equals cosecant of what angle, right? So, well, cosecant is restricted. So let's talk about cosecant. Cosecant inverse is restricted, okay? Cosecant inverse is restricted to where? Can you tell me what the domain is of cosecant inverse? I'm gonna wait for a little bit. Cosecant inverse. What is the domain of cosecant inverse? I hope you wrote down from, oopsie, negative infinity to negative 1, taking a little break, right? Union that with 1 to infinity. Then, of course, I will ask you what the range is for cosecant inverse. Did you write down negative pi over 2 to 0, not including 0, union that with 0 to pi over 2 in class? Okay. And when I'm asking you these questions, I don't, at this moment in time, I don't expect you to have it at the top of your head, okay? I don't expect you to have it all known or memorized. And if you don't, it's okay to look back at your notes. You just need to know where to look. So these right here are all the important stuff that we, or you should have written it down from class, okay? So the question is, hey, what do I need to know? What is it that first, let's talk about quadrants as well, okay? What 2 quadrants do you think this is? 1, everything is in 1, that is true, and 4, okay? And not including 0, so let's check this out. So 0 is not part of my range of cosecant inverse. Okay, so everything has to come from 1 or 4. Would you agree that this is a positive 2? Red pen, positive 2. So it has to come from quadrant number 1. Cosecant, you can think of it as sine reciprocal, right? So hey, is it okay to say, hey, this is really 1 over sine of that angle? So now you can flip that. So what do you think it is? You can even think like this, okay? What if I flip this? Would I flip that? Would you agree that I need to flip this? Can I think of it like this? 1/2 is now sine of this thing, okay? These are all equivalent. This is equivalent to that, which is equivalent to that, okay? So sine of what is 1/2? Did you say pi over 6? Yay! That is true. Sine of pi over 6 is 1/2, okay? So guess what? This box now gives a pi over 6. So cosecant inverse of 2 is pi over 6, okay? And that belongs in quad 1, which helps us out. All right, now secant inverse of 2. Because this is the first time that we are using secant inverse and cosecant and cotangent inverse, I'm going to write down the equation, okay? Y equals secant inverse of x, the domain. Can you write down the domain for me? is exactly the same as the cosecant inverse. Okay, so from negative infinity to negative 1 inclusive, then from 1 to infinity inclusive only at 1. The range, do you think the range of secant inverse is the same as cosecant inverse? No, slightly different, right? The range is inclusive from 0 to pi over 2, not including pi over 2. Union that, pi over 2 to pi. Okay. So this is all of the info we gathered during class. So how do I solve this problem? Secant inverse of 2 equals some answer. Don't know what that answer that is? Let's rewrite then, okay? Rewrite. This is the output of my inverse, so now it becomes the input, okay? So secant of what? Same box, right? Is 2. Another equivalency that I can think of this is 1 over cosine of this same box equals 2, okay? And if you don't feel like thinking in the denominator form, I can flip this. If I flip that, I will flip this. So this is cosine of that box equals 1 over 2. So cosine of what is 1/2, which is exactly the same as secant of what is 2. Because it is a positive number, I hope that we can see, because secant inverse is going to be from quad 1 to quad 2, not including this piece right here, pi over 2. So it's 1 or 2, not including pi over 2. Because it's positive, all answer for this one has to come from quad 1. So what should we have here? What should we fill in our box? Did you say pi over 3? Of course. Yes, it is. Okay. So guess what? Secant inverse of 2 is simply pi over 3. Okay. And how do you know that? You need to know that from our unit circle, and that's why I told you early on it was so important to have it all memorized. Okay. Next one. C and D are both dealing with cotangent inverse. Are we ready to move up? So let's write out our equation. Y equals cotangent inverse of x. So from class, can you tell me what the domain is? Did you say all reals? Then you are right. How about the range? What is the range? Did you say non-inclusive 0 to pi? Very good. 0 to pi is going to be from quad 1 and quad 2. Okay? Non-inclusive on both ends. That means I'm not including 0 and I'm not going to include pi. So only from 0 to pi non-inclusive. So this right here is the information that we got in class. So just like the other questions, right? I'm going to come up with some answer. It's cotangent inverse of negative rad 3. Because it is a negative answer, I know it has to come from quad 2. So I know my answer is going to be bigger than pi over 2. So what I'm going to do is I'm going to rewrite. This is the output of an inverse. That means it becomes an input of my regular. This right here is the input, so it becomes the output. Okay? Cotangent of something equals negative rad 3. Keep in mind that your answer has to come from quadrant number 2. Can you think of this as 1 over tangent of that box? Sure. Okay. You can totally think of it as 1 over tangent of that. Well, if you don't feel like working with tangent in the denominator, you can flip this, right? So it's really tangent of this same box is negative 1 over rad 3, which is equivalency of negative rad 3 over 3. Now, what angle could we use to fill in these boxes? All these boxes will have the same exact answer. What is the angle in quad 2? In quad 2 that we can use to fill in all of these boxes. What? 2 pi over 3. Oh, you're so smart. Okay, good job. It is 2 pi over 3. Okay, so the final answer of cotangent inverse of negative rad 3 is 2 pi over 3. Okay, here we go. Last question of this example. Cotangent inverse of negative 1. Again, cotangent inverse is restricted in quad 1 and 2. It is, okay, I'm going to repeat, it is negative, so the answer has to come from quadrant number 2. Okay. So I'm going to make a box. Are you ready for my box? My famous box? Okay, cotangent inverse of negative 1 is equal to some answer. I'm going to rewrite cotangent of that box as I'm switching input and output and input because I'm using a regular function. Cotangent of some angle in quad 2 is negative 1. Okay, keep in mind cotangent and tangent. I love it when the answer is negative 1 because they all have to be multiple of pi over 4. But because I need to be in quadrant number 2, it has to be 3 pi over 4. And so that means this is also 3 pi over 4. So my final answer is 3 pi over 4. Oh, you know what? I didn't really give you a joke, huh? Okay, here's a joke of today. Why did the student lick her homework? Why did the student lick her homework? That's pretty gross, right? Because the teacher said it has lots of pies on it. Get it? In math, we use this for pi, but because the teacher has lots of pie on it. Look, there's pies everywhere. Oh my gosh, pies everywhere. Have a wonderful day. I will see you next video.